Okay, here we have a Fluke 1900A. It's a what they call a multi-counter. It measures up to 80 megahertz, actually from 5 hertz to 80 megahertz by spec. But I suspect that we'll be able to go from about 1 hertz up to about 130 megahertz, and we'll test that range in theory. And it's in very nice looking condition, as we can see looking at the front panel. Nice shine, no scratches on the lens. Front panel looks very clean, very neat. There is a shine on the case. About the only negative thing on it was that at some point in time there had been some lettering written on here, which did my very best to remove, but there is still just a little remnant there that I don't know if it discolored the plastic or what, but you can see that, unfortunately. Otherwise, this thing is just a beauty. It's got all of the parts, the hub, the trim, everything. All the way around. Nice looking back. We've calibrated it with the rubidium standard. The rubidium up here is feeding a 10 megahertz signal. It's accurate down to about 1,000th of a hertz. Right now, I'm only reading it to about the hundredths place, hundreds of hertzes. But we can take it down one step at a time. You'll watch it shift off to the left. The 1 will disappear. We pick up an additional 0, so now we're down to the tens of hertzes. There's a 1 hertz point. So we are down to the 1 hertz, and we see ourselves flashing 0 to a hertz. I can go to 1/10 of a hertz. It takes 10 seconds. We'll get an average in doing this. We'll see how far off we are here. And we are momentarily, we are at 0.6 hertz away from 10 megahertz. So it is has been calibrated as closely as I could get it. I wish I could tell you for certain that it's going to hold this. I will test it, but okay, we've had this Fluke running for about 48 hours. It's completely temperature stabilized, and it's still got the 10 megahertz signal from the rubidium on it. As you can see, we're reading 10 megahertz, in this case down to the hundreds of hertzes. Let's go ahead and change the range down. There's to the tens of hertzes. This is down to a hertz. Alright, let's go for the 10-second average. And I think we're going to be pleasantly surprised here. She's been stable for hours. Okay, here we go. So what this is telling us is that we have 10 megahertz to better than 1/10 of a hertz on this unit. Now you don't get that without a price. You have to let this unit warm up and stabilize. But if you don't mess with the adjustment, it is correctly adjusted right now, and it will, after about 24 hours, warm into this kind of a condition. So if you turn it on cold and you just need to do a general measurement, no problem. Go ahead. At worst, you'll be a few hertz off, but in most cases that doesn't matter. But if you're doing something critical where you really want to get it nailed down to the hertz, you let it warm up overnight, come in and do your measurement the next day. And this is the kind of accuracy then you could hope to get. So, thought I'd show you that, and we'll move on. Okay, right at the moment we've got another 10 megahertz signal, this time coming from this PTS 500, a digital synthesized frequency generator, and we're going to use that frequency synthesis to provide the signals that we wanted to test this unit with. Right now I'm going to take her up, I'm going to add another 100 megahertz to this, so we should pop up to about 110. When that happens, the 1 will go off to the left, so you have to assume the 1. We see we're running 109.9998. Alright, so it looks like we're good to about 110 megahertz with this unit. 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's 99.9999 megahertz, or 100. Okay, let's get a little bit of light off of it. And let's take this unit now from 100, and we're going to go backwards. There's 90, 80, 70, 60, 50, 40, 30, 20, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 megahertz, 900 kilohertz. Let's go ahead and raise ourselves up. There's 900 kilohertz, 800, 700, 600, 500, 400. That's about as low as I'm going to go on this PTS. We're going to move ourselves now to this Hewlett-Packard 3320, and we'll complete the count from 400 down. All right, here we are at 400 kilohertz. There's 300, 200, 100, 90, 80, 70, 60, 50, 40, 30 kilohertz, 20, 10, 9, 8, 7, 6, 5, 4, 3 kilohertz, 2, 1. Okay, there's 900 hertz, 800, 700, 600, 500, 400, 300, 200, 100, 90, 80, 70, 60, 50, 40, 30, 20, 10. There's 9, 8 hertz, 7, 6 hertz, 5, 4, 3. Alright, at this point we're going to go to the 10-second average, give ourselves an extra decimal place. It's going to take us longer to make the reading, but it's going to be worth it. Alright, there's 3. Here's 2. Gotta give it one more count, so we get a full count in here instead of a partial. Gotta get a full 10-second average. There we go. There's 2. 1. There's 1 hertz. So we took it from 1 hertz all the way up to about 110 megahertz on a 5 to 80 megahertz counter. So she's in calibration. She is working very well. We're going to go ahead and set up to measure a period as well. Let's so for measuring the period of 20 hertz, you would get 50 milliseconds, because if it was 10 hertz, you'd have 100 milliseconds, and since you're running double that in frequency, then you're gonna cut the 100 down by half, so that'll be 50 milliseconds. So we are right now reading 20 hertz, 50 milliseconds on the system. If I go to 30, we should drop to 33 and a third. If I go to 40, it should be 25. 50 would be 20. 60 is 16.66, and so on. So we're reading our period accurately here. But we're gonna, if you drop below 10, you're gonna go overflow, because you're going to push into the hundreds of milliseconds, and so we see the overflow lamp come on. So we can really only read above 10 hertz as far as period goes. But by doing that, using a period, you're going to get a lot more digits, so you should get more resolution for a finer frequency measurement. Just have your calculator handy and divide about 1 over the period. Divide the period into 1, in other words, get your frequency. And there's a totalizer here, an event totalizer. So as we count our cycles coming in, we just add them to the count. So you wanted to count the number of pulses coming out of, say, an encoder or something. You could use the totalizer function to do that. Very useful for robotics or whatever. Count pulses. There is a check function. You get to check the counter. You're supposed to display 1 megahertz here, and it is right now. And we go back to frequency. It has a filter to filter out some noise. Right at the moment, we're so low in frequency. Let's give ourselves... There's 10 kilohertz. You can apply the filter here, and if there was any noise writing on it, you would filter it out. This would be high frequency. And then you've got an attenuator for the signal strength. So that's about it. The unit works very well. and it will come with a new set of leads. Along with it, you'll get this marvelous manual. You get a set of brand new leads, Geeter clip to BNC. The manual has everything you need to know about the unit, its theory of operations, some diagnosis charts, and then I finish up with 11 by 17 copies of the schematic diagram, so it's easy to read. So you've got a wonderful manual here, better than you'd probably purchase elsewhere. I throw it in for free. You get it with the unit, the same price. So happy bidding, and we'll see you again.